I welcome all of you to this lecture. Let us start this lecture with a thought process from one of the greatest freedom fighter of India, Subhash Chandra Bose. He says, one individual may die for an idea, but that idea will after his death incarnate itself in 1,000 lives. It is really a very great idea to die for an idea, and we must inculcate in our life so that it can enrich not only our life, but also the society at large. Let us now recall what we learned in the last lecture. In the last lecture, we initiated discussion about chemical propellant. Then we also found out that how a propellant is different from an explosive. Explosive is a kind of chemical propellant when fuel and oxidizer will be there in the same molecule. So, that one has to be very careful of handling explosives. Later on we looked at what are the criteria to be used for selecting a proper propellant for particular application. Then we looked at general characteristics of the propellant, and toward the end we classify the propellants into various categories based on the physical entities. That is based on the phases we classified the propellant. Like propellant can be broadly divided into 4 categories. One is gaseous propellant, solid propellant, liquid propellant and jet propellant. Today we will be discussing more about the solid propellant. So, as the name indicates, it is having the propellant will be in solid phase, and it is being used profusely for the rocket motors, particularly when it is used for booster applications. And question arises, what are the types of solid propellants we can have? As we had discussed earlier, we had basically looked at 2 types of solid propellant. One is homogeneous propellant, what we call a double base propellant, or sometimes we call the colloidal propellant, and other is the heterogeneous propellant, and we also call it as a composite propellant. Now, keep in mind that homogeneous propellant can be broadly divided into 3 categories: single base propellant, double base propellant, triple base propellant. We will be discussing little bit about it, but most popular among all these 3 is the double base propellant, which contains the nitrocellulose and nitroglycerin. And beside this, the composite modified double base propellant, that means double base propellant is basically modified adding the composite or heterogeneous propellant. You can combine homogeneous and heterogeneous together, and we can have a new propellant which called composite modified double base propellant. Apart from these 3 kinds of propellant, there is another one which is known as the nitramine propellants, and some of the examples is RDX. RDX means research development explosive, HMX means high melting point explosive, and sometimes it is also known as Her Majesty propellant explosive. So, and beside this several others are there which are high energetic materials, and you might be aware that these terrorists, they use the RDX. You might have read in the newspaper that the RDX carried by the terrorist might have been caught by the police or the paramilitary forces in India, because today India is infested with the terrorists from outside which are carrying RDX, which is explosive in nature. So, we will be now discussing one by one all these 4 kinds of solid propellant, and as I told earlier, homogeneous solid propellant can be broadly divided into single base, double base and triple base. Single base propellant is one which will be basically a single constituent which can be used as a propellant, and as it contains both the fuel and oxide. For example, nitrocellulose or the nitroglycerin can be used as a single base propellant, as both the fuel and oxygen constitute together in the molecule. So, therefore, when it decomposes, it can be releasing certain amount of heat, such that you can expand that in a nozzle and get the thrust. And in case of double base propellant, of course, the most popular one is nitrocellulose and nitroglycerin being used to produce a propellant, and the triple base is being also used nowadays, but it is rarely used. And apart from the nitrocellulose or nitroglycerin, the nitroguanidine is being used, around 40% or little less than that nitroguanidine being added to the nitrocellulose and nitroglycerin, which is used as a triple base propellant. If you look at the single base propellant, as I told earlier, can contain nitrocellulose. The formula is given here, and we know that cellulose is basically C6H10O5 as a N, and this is a containing carbon and hydrogen and oxygen together. You can see that carbon and hydrogen act as a fuel, and O can act as a nitrogen. Generally, this OH radical can be nitrized by replacing the ONA2, so that you can get a nitrocellulose. And it is used as an energetic plasticizer in propellant explosives, which is used from even in ancient time. As we go along, we will discuss about it. Cellulose of various kind, and this is basically a formula. What is being cellulose is represented by this chemical formula, and it is a single chain and then straight chain, which will be connected, consisting of carbon, hydrogen and oxygen. Other nitrate esters are the nitroglycerin, diethylene glycol dinitrate, triethylene glycol dinitrate, and triethylene glycol trinitrate, and several others which are being used, but as I told earlier, the most popular which is used in the double base propellant is nitrocellulose and nitroglycerin, as it is quite cheap and easy to manufacture. So, that it is being used very much, and nitrocellulose is available in gelatinized form, which constitute main component of the homogeneous propellant or the colloidal propellant, because the colloids are formed during this formation. So, therefore, it is known as, and sometimes people call it as a mixed propellant. And nitrocellulose is generally produced by nitrating the cellulose material using nitric oxide, as per the following chemical reaction. Suppose this is your cellulose, and when they reacted with x moles of nitric acid, what will happen? This OH2 radical will be substituted by the ON2, that is nitrate radicals, and as a result you will get this formula, that is C6H7O2N, and OH already basically this ONO2 is being replaced by the X mole, and then you will get X moles of water. And more you nitrate, basically more you get the various percentage of the nitrogen in the nitrocellulose. In other words, the OH groups in the cellulose are replaced with ONA2 group by this nitrating process, as I told earlier. And the energy content of nitroglycerin is dependent on the extent of nitration and type of cellulose material. And by nitrating cellulose, the extent of nitrogen content in the nitrocellulose can be enhanced to a maximum of 14.4% by mass. However, it is not being used very much, and if you look at the for propellant or explosive application, nitrogen content of N varies from 11 to 13.3% by mass, and its heat of formation increases with increase in N. If you can see that heat of formations are increasing with increase in the percentage of nitrogen here. So, that you can get a higher value. Generally around 12.5 is being used because it gives the best performance among all these kind of nitrocellulose. So, in earlier days these were also known as flash paper or the flash cotton or the gun cotton or the flash string, being flammable in nature because it can catch fire very easily. And in India, particularly in medieval times, this flash cotton and the gun cottons were being manufactured plentifully just to win a war and also for act as an ammunition. So, nitroglycerin is produced from glycerin or a polyalcohol, particularly alcohol containing multiple hydroxyl group, for example, propellant. And propellant, if you look at basically it will be like SC, S2C and S2C, there will be OH, this is straight OH, OH, and then this OH radical will be replaced basically with the nitrate radical ONO2. So, when it is replaced by that, this will be replaced by ONO2, and similarly this one will be replaced by that. So, ONO2 and this is ONO2, you will get basically the nitroglycerin as a, this is your nitroglycerin, this is your nitroglycerin. And keep in mind that nitroglycerin as an aliphatic with a straight chain structure with relatively low molecular weight, which is around something 227.1 kg per kilomole as compared to the nitrocellulose. And this is slightly oxidizer rich and remain in liquid phase in the room temperature. However, it solidifies when the temperature goes below 286 Kelvin, and so that it gets solidified and you can get a grain out of that. And nitroglycerin undergoes autocatalytic reaction at 418 Kelvin, and it can decompose into aldehyde NO2 gas very easily due to the breaking of weakest bond of ON2. This is the weakest bond which is getting broken down, so that it will be releasing heat, and that is why the nitroglycerin has an activation energy of 109 kilojoule per mole, and as I told that it can be decomposed easily and giving that. That is why not only the nitroglycerin, but also the nitrocellulose can be used as a single base propellant, because the nitroglycerin, nitrocellulose contain both fuel and oxidizer together in the same molecule. So, therefore, it can be used as a single base propellant, and also this can mix together, it can be used as a double base propellant. Double base propellant, as I told, this is the formula nitroglycerin and this is your nitrocellulose, and double base propellant made by plasticizing the nitrocellulose and with an energetic compound of nitroglycerin, that means you mix together and then we can form a double base propellant. Let us look at a typical double base propellant. Of course, the constituent will be different depending on the design being used for a particular application. And if you look at this example of double base propellant, nitrocellulose with 13.25% of nitrogen is basically 51.4 percentage by weight is being used, and which act as a fuel, and we call it as a basically polymer. And nitroglycerin is used 42.93%, which act as a plasticizer, and also it is act as an oxidizer. It is a explosive plasticizer. And beside this, these are the two main constituent of the propellants are nitrocellulose and nitroglycerin. But however, there are several constituents the additives are being used in this propellant composition with certain specific uses. That is, diethyl phthalate is used as a non-explosive catalyst to improve the mechanical properties, and ethyl centralate, which is around 1%, but it acts as a stabilizer such that autocatalytic decomposition of major constituents can be avoided. And potassium sulphate, which is used for to promote the smooth burning at low temperatures, which is a big problem with this double base propellant. But this percentage of the potassium sulphate is quite low, that is 1.2%. Carbon black, which is negligibly small, you can say that is 0.2. It is basically added to the transparent propellant such that transmission of radiant energy must be prevented. Otherwise, this radiant energy may ignite the propellant inside, particularly when there is a internal voids are there, and then it may get into something catastrophic failure due to the sudden rise of pressure inside the combustion chamber. And besides this very negligible amount of candelilla wax is being used, that is around 0.07. It acts as a lubricant, particularly during the extrusion process which is used to form the grain of various shapes. So, therefore, these are the constituents which are there. As I told earlier, different agencies or the manufacturers use different percentage of this constituent of the double base propellants, also composite propellants. But however, this is the typical one what you should keep in mind with its utilities so far the other constituents are concerned. Let us look at variation of specific impulse and adiabatic temperature with nitroglycerin percentage, which is shown here in a typical double base propellant, and keep in mind that this is basically the theoretical calculation which is done by using equilibrium analysis. These are the properties of variation of specific impulse and adiabatic temperatures are estimated by using the equilibrium model. And you can look at the specific impulse is being shown on the vertical axis, in the horizontal axis the nitroglycerin percentage are being shown, and on the right hand side, the right hand side vertical axis, the flame temperature is being shown. You can see that for 12.6% nitrocellulose, this computation is being done, and if you look at the ISP is increasing and reaching a peak value something around 80%, and so also the temperature is occurring at this is your T max kind of thing, and ISP is max is occurring at that. And generally this is the too much is being used, and if you have recall that in the typical example what we looked at it, generally 40 to 60% is being used because of fact that it is a very higher percentage which is will be difficult to cast it and also extrude it. So, therefore, that is not being used, although you are having a higher ISP because the temperature is higher which you are getting. Of course, ISP is controlled by not only the temperature, also the molecular weight. Lower the molecular weight, higher will be ISP, that we had seen earlier. So, therefore, generally you will have to use around something 40 to 50% or 60% of nitroglycerin. Let us now look at how to manufacture a double base propellant, and there are two methods, namely the casting and extrusion are generally used for making of the double base propellant, and casting is a process which is preferred for making a very large size propellant grain, whereas the extrusion is being used generally for smaller size, but the advantage with the extrusion that it can provide you better mechanical properties. Whereas the casting process can be used for making the propellant grain, double base propellant grain from very small size to a very large size. That is the advantage of casting method. And it can be casted in a mold, it can be casted in a casing. If it is casted in a casing, it is known as case bonded grain, and if it is casted in a mold, then it is known as the free strand grain, propellant grain, because it will be, you will have to fill this casing again with the this extruded or the casting kind of thing, the grain. So, for this manufacturing of double base propellant, the first important process is the casting powder preparation. In this case, there are various processes. The first one is the mixing. In this case, the solid ingredients like nitrocellulose, nitroglycerin and stabilizer, other ingredients are all grinded and sieved and mixed properly. Generally, very less amount of nitroglycerin is being added to start with, and then this casting powder are placed in a vessel with solvent, and generally the acetone and alcohol are used, and this casting powder along with the solvent is heated at around 35 degrees Celsius for several hours, so that a coherent dough is formed. And you might be aware that on heating there will be interdiffusion of polymers and a plasticizer, and which helps in kneading the two component system into a single monolithic grain. And this is a very important thing, so that it can be mixed at the molecular level. And after this, the dough is shaved into right circular cylinders by using the extrusion process, and the strands are being formed, which are cut into small pieces. The order of pieces generally 1 to 1 mm kind of things, and the length and diameter ratio is 1 generally being maintained, and this process is known as granulating. And after this, the volatile solvent is to be removed by the help of circulating hot fluid, generally air being used, hot air being used to dry this small pieces of the casting powder which is being produced. And then these granules are glazed with graphite, blended into large homogeneous lots, but these lots are to be screened to remove clusters, dust or some foreign materials, so that it can be used later on. And after making these casting powders, generally these powders are to be placed in a mold or a mortar casing with proper loading, such that this will be filling this mold at least by volume of 68%, and for that maybe a little more pressure, air pressure or some other things are being used, and so that compactness of the grain will be better, and this process is known as mold filling. And then this mold is subjected to a vacuum, which must be less than the 10 mm of mercury, in order to remove the volatiles, especially air or some gas vapors. After this, this this mold will be filled with a mixture of nitrocellulose plasticizers such that interstitial space is to be filled completely, and then this is to be kept at 60 degree Celsius for 50 to 100 hours depending on the what kind of compactness and the mixing is required for curing it. And curing is a very important one, such that there will be this interstitial spaces is to be filled, and the cross linking of the polymer will be occurring such that it can be properly made. And of course, this is the process by which the double base propellant can be manufactured, and with this process also the single base and the triple base propellant can also be manufactured. But there is another method which is being used, known as solventless extrusion method. As I told earlier, there is one is casting method, other is extrusion method. In this case, a slurry of nitrocellulose with water is agitated with periodic addition of nitroglycerin till this nitroglycerin and nitrocellulose paste is formed. And after that, the moisture in this paste is to be reduced at least by 30% using the method of suction. So, and then the other ingredients whichever is required are mixed and kept for 6 to 10 hours and then subsequently dried. And once it is dried, then it can be extruded using proper dye for it, and then of course, the extruded propellant grain is being prepared. And with this we will stop over, and in the next lecture we will be discussing about the composite propellant. Thank you very much.